right, good morning. Welcome to our online participants. Welcome to our in real life participants. I've had the pleasure of actually working with Gurion at Moody's for a period of time, and I'm very excited to see what he's brought us today. Gurion.
Everybody. I'm super excited to be here at my first Haystack and presenting at my first Haystack, and to be getting to share with you some of the really cool and exciting work that we've done at Moody's over the past 6 months to a year or so within the space of automating relevance judgments. So using large language models to automate judgments. So some of the things that I want to cover is just a brief overview of RAG systems and specifically some things that make Research Assistant a little bit on top of just a basic RAG system. Go over how we generally evaluate search and our traditional methods, how we solve some of the problems that we encountered with these traditional search evaluation methods, and then the rest of it is basically a case study in what we did and the results that we had. So how did we tune a large language model to act as a domain expert, and then how do we ground that large language model in expert judgments? And then I think the coolest part, the most exciting part for me, are the new directions that we can go within this space and some of the lessons that we learned. So without further ado, like, who am I and why am I talking to you? So I was born and raised in New York City. I wasn't always in the search space. I studied neuroscience in college, which I think is actually kind of interesting because my favorite part of neuroscience is learning and memory, and transformer is a mathematical homologue to the hippocampus, which is a lunch talk. But I decided to not become a doctor, and I instead went into data engineering. And after a couple of years of that, I wanted to go back to my roots a little bit more in data science and machine learning, and I went back to grad school, where I focused mainly in ML, NLP, and traditional methods. Shortly thereafter, I started at Moody's, which has been an amazing time so far, mainly because I got to help start our semantic search project. And our semantic search project has been really big in supporting Moody's new flagship product, Research Assistant, which is a Retrieval Augmented Generation application. And then recently, we've been really focusing on how do we evaluate these systems, because we have these really complicated systems, and it's non-trivial how we can evaluate a complex domain. So just a brief overview, like what is a Retrieval Augmented Generation system, and then more specifically, what does Moody's do on top of that to make it work for our use case? So going back to the long time ago of 2022, DeepMind published Retro, which is Retrieval Augmented Generation. Basically, they have offline embedding. But the thing that I think is really interesting about this is they're using GPT-3, and this was a flagship product. This was groundbreaking at the time. And then this was in February, and then a couple months later, ChatGPT comes out and starts blowing everyone away. And we now realize, hey, we can pair these two methods together. And we, since then, have had all of these Retrieval Augmented Generation apps. Oh, I forgot to start my timer. So David, give me times. Thank you. So the RAG is basically a two-step process. And so we have these dotted lines which show us an offline step. So we have a corpus. We can still use lexical search. There was a great talk yesterday about that. But for our use case, we're using semantic search. So we're using an embedding model offline. We're pushing our corpus through our embedding model, doing some pre-processing, some chunking, all that. And then we're storing chunk text as well as the embeddings in a vector database of your choosing. We're using OpenSearch. And then that all happens first. But then the user now wants to know something from us. They query. We use the same embedding model. And that query is then compared against all of these documents that have been pre-embedded, and we get the most relevant context. We have a prompt that we use, and then that gets sent to a model back to the user. So pretty basic idea, like pretty straightforward concept. But when you have a complex domain with many different data sets and stuff, that it's not always just going to work out of the box. And for us at Moody's, that's definitely the case. So we have the difference is that we have a lot of different data sources that go into this. So it's a research assistant, and we're doing research. Embedding is one of our main products, but we also have all different kinds of data sets. And part of the pre-processing that is really important here that I left out of the diagram is the intent detection and NER steps that happen in the pipeline, because what we can then do is filter our retrieval steps so we get more relevant documents. So when we want to be able to search against all of our different collections, be it research or organizations or other news or any of the other data that Moody's has, this intent detection, this named entity recognition really makes us able to filter down these data sets and figure out how to get the most relevant documents. So we combine everything, we get a final answer. We have a really powerful retrieval augmented generation tool with proprietary data. But Moody's brand is built on trust. So what are the things that need to go into RA to be able to trust it? And those things are that it's accurate data. So in the financial domain, if you have a rating come out wrong in your answer, that's going to be really bad for user trust. So we need to make sure that we have absolutely zero hallucinations. And we also need to make sure that the data we're pushing back is representative of the current data that we have. The other thing kind of going along with accurate data is that we need all of our results to be traceable. So we need the data to be accurate, and we need to be able to cite the place where we're getting our data from. And so I maybe could have put a demo in here, but in an RA response, almost every claim has some kind of citation on it and a link to the document at the bottom of the answer. So we have a system. How do we evaluate it? How are we currently evaluating it? And what are the problems with that? So first of all, like, what exactly does that mean? What are we trying to evaluate? So there are two parts to this because we have retrieval and we have generation. So I'm going to start with the end and talk first about the final generation step. So this is going to be the answer that the user gets at the end. So a long text response to a question. There are really good frameworks for doing this. We have Ragas, which are another team at our company is using to do evaluations, and we get metrics like faithfulness, which means making sure that our answers are grounded in context, that we're citing things. And you have response relevancy, like, is this answer that we're given actually answering our question? That's great and everything, but it's really evaluating the final results, and it's not evaluating the context that we're giving to the model. So that's what I'm really focusing on here, because we want to know that the step that we're on, that my team is involved mostly in, is actually giving the correct results to do the generation. Because if the results to the input step are bad, we kind of expect the answer to be bad, and then you might be faithful to the context that you're given, but you might just be wrong. And we need to make sure that that's correct on the search side. We want to make sure that we're able to continue to use basic, really easy and fast to compute search metrics. So we want to be able to continue just using precision, recall, cumulative gain, and all of that jazz. And we need this to be scalable because we have millions of research documents, and we can't have experts judge them all. Speaking of, I like ML and neuroscience and playing guitar, and I'm a software engineer, but I don't have a super grounded domain knowledge within finance. So we need to get subject matter experts to tell us, are we right or not? And these are people that have decades of experience, and they can say with certainty whether a chunk is relevant. And the thing that I think differentiates this is that we can't just use mturk, because you might be able to get many raters, but those raters also are very unlikely to have deep finance domain knowledge. And again, we want to be able to use traditional metrics. We want to know we have a search system. We're going to evaluate it like a search system. Nothing is really different there. So who are these expert evaluators that I keep talking about? They're experts. They're people who have worked in the domain for a long time. But there are problems with these methods, and the main two are that it's time intensive because humans are slow, and they have a lot of stuff on their plate. So we might have a task where we say, hey, we have hundreds of query chunk pairs, please judge them for us. And they'll say, no, we'll give it to you in 2 weeks and we'll do like 20 or something of that sort. Because they're producing research, they're doing all kinds of other tasks. The other thing is these are experts, they're top of their field, and they're highly compensated, which means that not only is it time costly, it's also money costly. So how do we get around this? Just a quick aside, we all probably know what these metrics are, but I want to make the distinction between these order unaware metrics, which is just precision recall and all of that, and order aware metrics like discounted cumulative gain, average precision, because within RAG, we've been finding, especially as models get longer and longer contexts, we're mainly worried, at least for retrieval augmented generation, not like search bar stuff necessarily, about the metrics on the left. And so those are the ones that I'm going to be discussing throughout the rest of this talk. But the ones on the right are super important as we are going to move forward into integrating semantic search through many other parts of our website. Yeah, so we have some problems. How do we solve them? We have an automated search relevance framework that I and a team of other super talented engineers have worked on building out, which is basically saying we have language models and they've seen the entire internet. So they've probably seen some stuff having to do with finance. And they probably could understand what we want them to do, understanding the task if we give them enough examples. Couple things about this that are really nice. They're a lot faster than humans. Instead of 2 weeks to get a judgment back, it takes 3 seconds. And they're a lot cheaper, even though we can note at scale this might become more and more costly. At a basic level, they're cheaper than humans. So what does our basic architecture look like? And then get into a couple lower level details. So there are a couple color-coded boxes here. And what do those mean? So the yellow ones currently are manual steps. The purple boxes are automated, and blue are things that exist to an extent outside of what we've built new. So the first thing that starts, which probably could become a purple box, is that we need a set of queries that we want to test. So we luckily have in production a user-facing chatbot. So we can harvest user queries. We can try to figure out ones that didn't work well. We can try to figure out hard ones. Right now, we're doing that manually, and we have sets of 20, 100, 500 to 1,000 queries that we might want to test. Then the step that I talked about earlier is that we need to make sure that we apply all of our filtering logic. And this is also where we set up some of our experimental procedures, because beyond just being a relevance judge, this is also a framework to be able to conduct search experiments. So we can put filters that we want. So say we want to try a new embedding model, say we want to try a new chunking method. These are all things that will go in to our search query bodies so that we can use filters and do search results on different algorithms that we've tried. And then the rest is kind of what you would expect. We call our search API. We get a list of ranked results. We collate those results. We do some prompt processing, and we send them to a highly tuned prompt to do relevance judgments. And we generate the metrics I've been talking about. And then the last part that's important are these two light yellow and dark yellow boxes. So maybe we can get rid of this one. But I want to note, this isn't meant to be just released, and this is going to run experiments indefinitely. Like there still is going to be, at some point, a human in the loop to decide whether or not we're moving forward with a production change. Just a couple lower level details. We have sample prompts that we've been iterating on this, so it makes it a lot easier if you have your templates stored in a common space, and then that's just parameterized. The most important thing that we came across is making sure that you cache or save your judgments somewhere. So when we run a query chunk pair and we get a relevance judgment, we make sure to store those 3 columns in a Parquet file in S3, because if you are running just a small change in your algorithm, say you want to change some boosts and see if anything happens, it's likely that you're going to get a lot of the same results, but just in a slightly different order. And I don't want to spend the money on OpenAI rerunning those judgments. So we have this judgment store And yes, you'll have to recompute a lot of judgments when you make a larger change, say to your chunking algorithm, say to your embedding model. But that's expected, and this is really to give us some cost savings and avoid costs when we're making smaller changes. Other thing, as I get into case study, the results that I'm going to show are based on GPT-4o, but models, as you all know, have been coming out super duper frequently. And as they come out, we test them, and some of the new ones are really, really impressive. So, David, how long do I have? 40 minutes. Oh, sweet. I'm going faster than I thought. Let's do a little prompt engineering. So let's just start with this very naive prompt, right? Like say, hey, I have a query and I have a chunk. Tell me if it's relevant. Depending on your domain, this might work, but it doesn't for us because, as you'll see later, these chunks are very dense. And it's unlikely that a completely naive model would know what to do with it. So what's the first thing we did? We made sure to give it a very defined role, but moreover, we give it both a persona and we give it this idea of a role. And you can kind of get creative with it. So yes, we said, hey, you're an analyst at Moody's and you're an expert in producing this research in finance, but you're also a search expert, and that just works. It decides, hey, I'm also a search expert. So it understands what relevance engineering is, and that's just a pretty simple prompt engineering trick that showed impressive results. The other one with role type stuff is that you give it a setting. So the setting we realize works is, hey, you have a dumb intern that made an algorithm, and you need to make sure that it works properly. And saying, hey, you're in a reviewing role rather than you are the only one doing this role also gave us pretty impressive performance boosts. So what might something like that look like? So we still have our query chunk pair. We still say, hey, at the end of the day, you need to tell us if this is correct. But now we also have you're an analyst at Moody's Ratings, and you also have a dumb intern that made an algorithm, and we need to make sure that it works properly. Next thing that's important is to make sure that you're really clear and really explicit within your domain of what's important. And some other tricks that we came across in here to make this work better is that, yes, we need specific instructions, but you can also split those instructions into almost a grid search of a rubric when you say, hey, you have subtasks. So we have query intent detection, we have just general search relevance. So let's say, hey, 70% of your evaluation is going to be based on relevance, but note that 30% of the weighting of your score should be, is this on topic or not? And setting up those kinds of subtasks is another thing that gave us performance benefits. And then within each subtask, you need to be really clear. So you want to give definitions, you want to go over your edge cases, and yeah, so imagine you're having someone else do the rating for you and really treat this as a human, because the more explicit you are, the better performance you can expect to get. But there is a trade-off. If you get too explicit, then you might stop generalizing, and we don't want those. We don't want that to happen. So now what does this look like? We still have our prompt, we still have our role, we still have our task, we still have our evaluation, but now we have a rubric involved. So our experiment, we're doing binary judgments because we figured we could try to reduce cognitive overload on expert raters. Thank you, David, for your input there. I will say, there's a lot of stuff I know in grad school. I did work doing ordinal analysis using different Likert scales for raters. At the end of the day, it probably doesn't matter. It would be nice to know more. So we also have a prompt that goes 0, 1, and 2 to give a somewhat relevant idea. One of the more important ones on here is that if you don't understand something, don't try to guess. And if you're unsure, just say it's not relevant, because at least in our use case, it's more important to not give bad information. It's more important to not give bad information than it would be bad if we don't give good information. I didn't phrase that properly, but I hope that the point made it across. And then the last thing, which with reasoning models coming out, I will say is having slightly less of an impact, and cool thing that I'll talk about at the end. So in 2020, we found out few-shot learning works really well on language models. And we know that examples showing, hey, this is the criteria, but these are different use cases and examples that you have. So these are positive cases, these are negative cases. And these are hard things that you might need to figure out, and these are edge cases. So giving edge cases as your examples is probably a pretty good place to start. And the other part of this is, and again, with reasoning models getting better, this has had less and less of an impact and might just lead to token cost. But having a model in your structured output to make sure that you're giving the correct results, having it explain its reasoning before giving an answer makes the thinking part be within the context window that the answer is generated in, because these are autoregressive models, so each token builds on everything it has. So making sure your explanation is there before generating your answer rather than the other way around is pretty important. I said this a couple times. So now what does this final prompt look like? And there's going to be a lot more stuff that we're going to do that is not here, but this is generally where we're at now. So we still have our role, we still have our task, we still have our storing criteria, and we still have now, hey, give me JSON format. So that we haven't seen before, but that's part of this, is saying, hey, we now have examples of query chunk pairs, and this is what the output should look like. These are things that all helped. So it's great and all that we've developed a prompt. That's a fun time. It's a lot of edge casing and figuring out, but the thing that actually matters is if our relevance judgments align with expert judges and domain experts. So how do we stack up, and what is the experiment that we did? So we got 8 expert evaluators, and this isn't a huge number. Like, I know you'll get experiments where you can use mturk and you have like n equals 1,000. We don't have that luxury, or hopefully we will at some point. But this was pretty good for us just as a starting point. And again, maybe fewer example pairs, but we have 75 example pairs, which is more than 25, so we can assume there's some distribution there. And these are real query chunk pairs that were retrieved that might have been hard for the language model, might have been like bad responses, something like that. They might have been good responses. Tried to come up with a general idea. And then what the task is okay, we have our judges answer, like, is this relevant or not, yes or no. But the other part that we had to help us with our tuning was after they made their judgment, we had a hidden column show up, which says, if your judgment is different from what our model judgment is, explain why that is. Like, explain your reasoning for your answer. And that helped us with our tuning. So I think if you have the opportunity to do this, that's a good thing to implement. So a couple cases, and warning, these are going to be dense text, but I'm going to do like show of hands thing. I can't see any of you, but I'm going to do my best. So this is what our experts see. And I'm going to give you guys like 30 seconds just to read through this, and then tell me if you think, or we'll say raise your hand if you think the query is the chunk is relevant to answering the query. Say, does this help you answer? I'll wait like 15 seconds. I know it's a lot of text. Okay, that's probably not enough time, but grand answer. If you think that this is going to help you, raise your hand. I can see you now.
I see very few people
Okay, so we
understanding this text.
Yeah, I think so. So we've got like maybe 30% of you think this is relevant. You guys are experts apparently. So I don't know why. I didn't know, but apparently this indirectly addresses the company's operational risk. But it's not fully relevant to the query, so maybe this would have gotten an answer of like 1 or something. The other judges said kind of similar things. These factors relate. This guy said true, but also you're not up to date because somehow this expert knows from just looking at this passage that this is outdated, which I think is pretty impressive. Our Judge Moody's thought it was irrelevant, But I think the thing to note is that since we make a given explanation, we can see, where is this guy? These efforts may indirectly relate to operational risk mitigation, which indirectly addresses companies' operational risk. So the judge, our automated judge, knows what's going on, but it shows that we could use a little bit of prompt tuning on a hard task to make it better performance. I'm going to do this 2 more times. You don't have to give your answer. You can do this part on your own. This guy says, yeah, this is relevant. This guy says, you're somehow outdated. This guy says, yeah, you're relevant. Judge Moody says, it does not directly address a SWOT analysis, and you need a more comprehensive overview of strengths, weaknesses, opportunities, and threats. So what this is saying is our prompt is a little too specific. We're saying your document that you retrieve needs to be able to fully answer the question rather than this would be helpful to answer the question. And that's a part of prompt engineering that we also worked on. Last one, because I thought there were some interesting things to come to this. The experts all said this is irrelevant because this doesn't help create a credit profile, but the model thinks it does because it has a credit rating, and that might be useful. All 3 of these examples are examples where our model does not agree with the consensus, which doesn't look great for me, and I did this on purpose because when we look at all of our raters, and note there's only 6 raters here because 2 of them didn't complete all of them, and I didn't want to skew our results. So we have Judge Moody's all the way on the left. We have Judge Moody's on the top. We have each rater here. They don't agree with each other very well at all. Experts 3 and 4 really don't agree with each other, with any of the other guys. And then when we take a consensus, so these last 2 columns and since we had an even number of raters, taking a consensus was also a little tough. So I have 2 cases, one where we say ties are yes relevant, and one where we say ties are not relevant. I'm gonna just go, I'm optimistic, I like things. So I'm gonna say, we're gonna go ties are relevant. And the judges all agree more with a consensus judgment than they do with any other individual rater. And I didn't put the Fleiss Kappa scores on here, but when you do inter-rater agreement, you only get a moderate agreement, which makes sense, but then you get higher agreements with a consensus judgment, which I thought was interesting. And Judge Moody's agreed more with a consensus judgment than any individual rater, except for 6. They're a language model, clearly. Expanding this out a little bit, just to, if you had a hard time reading the numbers on the last slide. So this is just the last 2 columns, the consensus columns that I was talking about. And we see high-ish, majority, yes. So yeah, if 50% or more said relevant, majority rule. These guys are obviously they say more stuff is true because they don't agree when ties go to false, and you can make other kinds of judgments based on this data. If we get more raters, I'm really interested to see how this shifts. The other thing that we can look at is another way of just looking at the column of only looking at how does each rater agree with Judge Moody's. None of them really agree. They all agree 70-ish% of the time, which is interesting because I think at Doug's talk yesterday, the LLM raters were about 70%. But the majority generally agree with Judge Moody's. And then a quick note on false positives and negatives. So this has been good for us because we have relatively few false positives. We don't have the model say, yes, this is relevant. So hopefully when we do our tuning, these things won't go through as relevant. And I care less about false negatives, just for reasons that I discussed earlier. But these are statistics. This is generally how the breakdown looks. Now back to the actual challenge we've been trying to address, which is time and money. So it took 2 weeks for these guys to do this experiment. We probably could have asked them to do it faster, but they have a lot of stuff on their plate. And 2 of them didn't finish all of the examples. As I said, I don't know how much they make. I'm not going to ask, but I can assume that their time is expensive. On the other hand, Judge Moody's, for 75 document pairs at 3 seconds per judgment, we can parallelize those and run them concurrently. Generously, it takes 2 minutes to run these, and all of the judgments get done. And then it's also much cheaper. So if you look at every model just by like general token output, we can calculate generally. So our prompt plus the, okay. The prompt plus the token, plus like the chunk that and query that we're putting in, let's call it 2,000 tokens on average. And we constrain our output. Our explanations need to be short. And then just based on how much models cost to run, this is cents on the dollar to run the same experiment. So within 2 minutes and 50 cents, we got comparable judgments to financial domain experts. And thing to note, as we get more and more people, this may be more and more expensive. So the part that's most exciting for me is like, where do we go from here? What things will we work on? What did we learn from this? What are some caveats to avoid? And the first one is, how trustworthy is this? As I alluded to earlier, like, we don't have 100% agreement with experts, but I also don't know if that's as much of an issue because the experts don't really agree with each other. But more importantly, can we trust this to make business decisions? And that's the reason why that box in our architecture is still yellow. So the main ad here is that we want to use this to be able to iterate faster. We want to be able to run more experiments more quickly and get more immediate feedback, so that we can figure out like when we actually need to reach out to domain experts and when we actually need to use their time. So it makes it less costly for everyone. So we can run experiments more cheaply and faster, and we're also not wasting people's time. So that, I think, is probably the biggest value add here. So things that we can do, we need to do more prompt updates, obviously. We can take more advantage of the RA metadata, query intent detection, and figure out like what other subtasks will help us. So yeah, like, let's have more subtasks based on different things. These last two slides are my favorite ideas, and I'm curious to hear thoughts later. So the first one is the idea of synthetic data. Now we have a judge-ish, we'll call it a judge, that is generally good at judging relevance. But I don't want to spend money on OpenAI constantly. Even though I like Anthropic, I don't want to spend money on Anthropic either. So how can we move away from using hundreds of billions of parameters language models to using hundreds of millions of parameters language models? Well, the thing is that BERT is really good at a natural language inference of just, let's frame like logical entailment. So we can frame this as saying we have a premise, query, and we have a chunk, and we have a conclusion. So does the chunk entail the query, basically? And one of the things I'm going to be testing out is using our outputs of this relevance judge as inputs to train a much smaller encoder. So this is taking some inspirations from first a paper, and then another time that I built on top of this paper, so I recommend reading it, where they trained a small encoder using explanations from human raters, fine, but I did it synthetically with GPT-3, and GPT-3 did a really good job at gaining better performance on an NLI task. So I assume Claude 3.7 will do even better. So that's one thing that we can do to try to bring down costs. The other is we saw that the judges didn't all agree with each other. So let's try to ensemble them ourselves. Like, we can either have different model prompts all tuned for slightly different subtasks. So let's, instead of having a subtask with like many subtasks within the prompt, we can split that prompt out and say we have experts within their subdomain, and then weight them and ensemble them in some way so that we get a final relevance judgment. So basically, what we saw with agreement of our main prompt had agreement with the majority, try to replicate that with all experts and get that kind of performance. So yeah, thing to note here is that if we have an ensemble, it'll raise your costs by the number of calls you do per judgment. So if I have 3 like sub app guys, it'll raise costs by 3 because I have that many more calls. Maybe 4 because I probably want to have a last guy at the end. The last one, I traditionally am based in like basic ML methods. So just the idea of not actually doing ML like on data, but how can we use this golden age of AI to do the prompt engineering for us? And I've gotten pretty promising results out of this. So we now have a data set of expert judgments, and many of them are explained. So what we can do is just iterate on our prompt and say, we're going to split this. So I want to make sure that I have a holdout test set. That's important. We don't want to train on our test data. But run all of in our training set, highlight where our prompt does not work. And then we cherry pick those examples and feed them into another tuning prompt and say, you as like your colleague failed in figuring this out, or your prompt failed in figuring this out for these reasons. And then we have query chunk pair with explanation of why it's wrong. And then we use another tuning prompt to change our judgment relevance prompt and just iteratively recreate our prompt and update it. Make sure that you do things like set a stopping condition or like number of epochs. You don't want this to run indefinitely. But preliminary results are like more exciting than I thought they would be actually. I let this go for like 3 iterations on a pretty small, on like 50 queries, and I had a holdout test of like a holdout set of like 20, and I gained 6 or 7% performance on my holdout test set. So clearly, like, yes, I need more judgment pairs judged by experts to say this generalizes well and this is actually good performance. But I think really exciting application of language models within the relevance domain. So yeah, this is everything we talked about. So prompt tuning is probably the most important of this whole exercise. The other most important thing is that you make sure that you are grounding your results in a complex domain within expert judgments. Some of the techniques that are important to remember would be role prompting, specific examples, rubric grading, and giving the few-shot learning idea, explaining your reasoning. Main takeaway, this is a tool to iterate faster. This isn't just fully a let it fly, update our algorithm type thing. But we do get a huge amount of cost savings and a huge amount of time savings for our team to be able to iterate faster on our experiments. And I'm really excited to see how some of the experiments go in what I talked about in the last couple slides of where can we go from here. Some people on my team did a lot of really great work here, and one person that's not on here is Joelle sitting in the audience, but particular thanks to David Fisher, who had the opportunity to introduce me. Shuping, our director, Sandeep, our tech lead, and Jeff Capobianco, who sadly just had his last day at Moody's. Good luck to him, but he did a lot of great work on setting us up with our domain experts. So with that, I thank you for listening to me for the last 45 minutes. And please ask me any questions you have. I love to talk about this.
Thank you, Gurion. I'm sure there's going to be many, many, many questions. Make my life easy. Stand up, get close to the edge of the row so I can get to you faster. And I have a number of questions from the online group as well. Yes, the slides are hard to read for some people. We're sorry. We really can't do anything more about it. We've tried very hard to improve the transmission rate, added a private network. We're shipping them out as best we can. I have to scroll all the way back to the first one. How do you label your document data set for computing cumulative gain? nDCG in this case.
How do I label my document data set? So I guess using the relevance judgments. So this is exactly the thing that's supposed to be used to do that labeling. So there's a 2-step process. Like, you can compute the metric on search results, but you need the search results to be labeled. So this is just creating a labeling tool effectively. Does that answer the question?
Thank you.
Really great talk, thank you. My biggest question is, how do you know when your LLM judges are starting to fall apart, and you need to get back to your experts to get more training data? Like,
It's a great question.
Where's the threshold? Is there a signal? Like, what do we do here?
Yeah, I mean, I think the important thing to have is like performance metrics on your data. So the nice thing is that we do have a team monitoring the generations too. So if we get any signal from them, but it's a great point. And it's a reason why we say we have to keep a human in the loop. And it's a reason why I tried to push the fact that this is great as an experimental tool and great for our internal team to use, but it's not just a substitution for expert judges entirely. What it allows you to do is make many changes quickly and figure out when you need to go to those expert judges.
And Cheng asks, are your edge cases examples in your subtext prompts static, or are they dynamic through some retrieval mechanism?
So those are static. We figured out edge cases that we need to handle. Some of those are involved in like the few-shot learning that I talked about. Of these are examples that look like they would be hard or were hard for our expert judges. And then other ones are ones that we looked at of trying to make sure that it doesn't that it's not overly specific, that it doesn't overgeneralize. And there are a lot of trade-offs in choosing that. I would need to think a little more about like more specific things to say on that, but I would just say that's probably the hardest part of this whole exercise.
Very nice talk, Gurion. I was wondering if you ever expose your LLM comments to the SMEs, either during the rating process or afterward, and compare their responses to those?
I don't think we did in this example. I think we just showed the judgment from what I remember. But that would be a great thing to implement in a next iteration. And you can kind of start making this loop of model to SME back and forth of saying who's why, and almost have a discussion that way between the two.
And Deep asks, experts sometimes disagree. Do you resolve dissent majority vote, arbitration, or by modeling a distribution of relevance labels?
For this, we just did majority vote. We didn't have that many raters, so it didn't really make that much sense to me to try to throw modeling on it. As we get more and more judges, and more ratings, that's definitely a technique that would be worthwhile to employ.
Great presentation. Thank you so much for showing all of the approaches you've been working on at Moody's. You know, with trust being such a big part of the brand and your approach, how have you been looking at more agentic workflows, building in LLMs into the human go, no-go decisions, or the human parts of the feedback loop, and where the challenges you see in there?
So I personally have not put agents within the go, no-go decisions as of yet. I don't know if there are plans to. I that's maybe above my decision-making level. But I'm sure as these things get better and better and get better performance amongst tasks, that's something that could be investigated. I think it is important from a business perspective to have at least some decision makers in the loop.
And Deep also asks, which base model gave the best cost performance trade-off? Did smaller fine-tuned models ever match foundation models?
I believe it. So all of these results are based on GPT-4o. But Sonnet is really good. I think it might cost a little more, so you might get better performance. And then the O3 mini models have been really good as well. The reasoning models make a definite change.
You mentioned that you had the model explain its reasoning prior to answering the prompt. Can you elaborate on how you utilized those explanations as part of the tuning?
Sure. So the main reason for the explanation is to make sure that the model's own reasoning is within its context. So like some idea of reasoning is within the context window to generate just a numerical answer. Because if you do it the other way around, you have an answer based off of the prompt and stuff. And then fine, it's explaining stuff, but it's not actually using the explanation when it's generating tokens. So switching the order of those is what's important. And then honestly, just like reading those and seeing why it may have thought a different chunk is relevant or not based versus a human judgment is probably really what goes into that. I don't have a great explanation for like how I did that other than smell test of this is how it explained its reasoning, and I can make some changes based on that reasoning to try to figure out like maybe I add another edge case. Maybe it's something to do with like our search algorithm. Maybe I need to fix our recency boost, and it's not having to do with this chunk query relevance.
We have time for one long or two short questions.
Okay, I'll have a short question. Thank you for a great presentation that shed a lot of light on the whole concept. I want to step back a little bit and maybe kind of go back to the premise of this method.
Mm-hmm.
So, and this is actually a question for anybody doing LLM for judgment. Is the fundamental premise that GPT 4.0 and other models actually know something about finance?
Yes.
And if so, did you actually find out that it seems to know about finance? And then I'll ask one more thing: is do you think GPT learned about finance by scraping the Moody information? Thank you.
So I like chess. So I like Magnus Carlsen, and I think he said let the chess speak for itself. So let the model speak for itself, and it showed like it understands finance. Like it knows what all of these methodology techniques are. It to an extent seems to just know what it's doing. It's probably trained on textbooks. I don't think it's trained on proprietary data, and that's another step that we can take, and that's why I said I want to do some fine-tuning stuff. But yeah, it clearly picked up on it. It's trained on the entire internet, and there's a lot out there.
I'll be quick. Okay, hypothetically, you've gone through iterations, you've got more judgments, your judge Moody's starts to go from 70% to 100%. At what point do you say your judge itself is now an expert and remove the humans from the loop? Like it's cheaper, it's better. You've gone through the iterations with confidence. You say that this can now judge content as good as your experts ever could. Is that the future that you get to?
I think when we get there and our managing directors say that that's the case is when we can make that decision. Yeah, I hope we're not all taken out of the loop at some point. This is exciting and really scary at the same time to speak to that. So yeah, there's definitely a threshold. I think there are a lot of conversations to have about where that threshold is and what that means. Hypothetically, sure. Yeah, we're not there yet, but sure.
Thank you, Gurion. Everyone, let's thank our speaker again.